Productivity measuring what matters. In our last lecture, we established what operations management is and why it matters. Today, we go one level deeper and ask, how do we actually measure whether an operation is performing well? The answer is productivity, one of the most important and most misunderstood concepts in business. By the end of this lecture, you will be able to calculate basic, labor, and multi-factor productivity, measure a change in productivity over time, and explain what drives productivity improvement. Imagine two restaurants right here in Brooklyn. Same neighborhood, same menu, same price point. One is packed every night and turning a profit. The other is half empty and barely covering costs. From the outside, they look identical. But inside, one operation is getting more output from every dollar of labor, every pound of food, every hour of kitchen time. That difference has a name, productivity, and it is the single most important measure of operational performance. What is productivity? Productivity is simply the ratio of outputs to inputs. How much did we get out relative to what we put in? This sounds simple, but it is enormously powerful. A firm that produces more units per labor hour than its competitor has a cost advantage. A nation that improves its productivity over time raises its standard of living. Every operations manager, every business owner, every supply chain professional needs to understand how to measure and improve productivity. The productivity formula. There are three main types of productivity measurement. Labor productivity, the most commonly used, measures output per labor hour. Machine or capital productivity measures output per machine hour. And multi-factor productivity, which we will cover shortly, combines all inputs into a single measure. Each type answers a different question, and each is useful in different contexts. Solved example. 1. Labor productivity. Let's work through our first example. Flatbush Deli, a fictional Brooklyn sandwich shop, produces 480 sandwiches during a 6-hour shift using 4 workers. What is the labor productivity? Step 1. Identify your inputs. We have 4 workers each working 6 hours, so total labor input is 24 labor hours. Step 2. Apply the formula. 480 sandwiches divided by 24 labor hours equals 20 sandwiches per labor hour. That is our labor productivity. Notice the unit sandwiches per labor hour. Always state the unit. It tells you exactly what you are measuring. Additional example, basic labor productivity. Let's try another labor productivity example. A garment factory in Sunset Park produces 1,200 units of clothing per day, running one 8-hour shift with 15 workers. Total labor input is 15 workers times 8 hours, 120 labor hours. Labor productivity equals 1,200 divided by 120, which is 10 units per labor hour. Notice how the same formula applies regardless of the industry, sandwiches, shipments, or garments. The unit of output changes, but the logic is identical. Solved example 2. Labor productivity in dollars. Now let's try productivity measured in dollar value, which is often more useful when comparing across different types of output. A Crown Heights logistics firm processes $36,000 worth of shipments per week using 5 workers each working 40 hours. Total labor input is 200 hours. Divide 36,000 by 200 and you get $180 per labor hour. This tells the manager, for every hour of labor we invest, we generate $180 of output. If a competitor generates $220 per labor hour, that is a significant cost disadvantage that needs to be addressed. Additional example, dollar value labor productivity. Here is another dollar value example, this time from the service sector. A Bay Ridge dental practice generates $18,000 in patient billings per week, using 3 hygienists each working 30 hours. Total labor input is 90 hours. Divide 18,000 by 90 and you get $200 per labor hour. Compare this to our Crown Heights logistics firm from example 2, which generated $180 per labor hour. The dental practice is generating more revenue per labor hour, but of course the input costs, overhead, and capital requirements are very different. Productivity ratios are most meaningful when comparing the same operation over time or against direct competitors. Multi-factor productivity. Labor productivity is useful, but it only tells part of the story. What if a firm improves its labor productivity by investing heavily in expensive machinery? Labor productivity goes up, but total cost may actually increase. Multi-factor productivity, or MFP, solves this by combining all inputs, labor, materials, energy, capital, and other costs into a single denominator. This gives a more complete picture of overall operational efficiency. Solved example 3, multi-factor productivity. Here is our multi-factor productivity example. Atlantic Avenue Bakery produces 800 loaves per day at $4 each. That is $3,200 of output. Their daily inputs are $400 in labor, $600 in materials, $100 in energy, and $150 in overhead, totaling $1,250. MFP equals 3,200 divided by 1,250, which is 2.56. The interpretation: for every dollar of total input, the bakery generates $2.56 of output. If that ratio improves next month, operations are getting more efficient. If it drops, something is wrong. Additional example, multi-factor productivity. Let's work through another MFP example. A Flushing print shop produces 500 custom orders per week at $12 each, that is $6,000 of output. Their weekly inputs total $4,000, $1,800 in labor, $1,200 in materials, $300 in energy, and $700 in overhead. MFP equals 6,000 divided by 4,000, which is 1.50. For every dollar of input, the shop generates $1.50 of output. Compare this to the Atlantic Avenue Bakery from example 3, which had an MFP of 2.56. The bakery is generating significantly more output per dollar of input, which suggests either lower input costs, higher output value, or both. MFP comparisons like this help managers identify where operational improvements are most needed. Measuring a change in productivity. Calculating a single productivity number is useful, but the real value comes from tracking change over time. To measure a change in productivity, you follow 3 steps. Calculate productivity for period 1, calculate productivity for period 2, then compute the percentage change using the formula, new minus old divided by old times 100. A positive result means improvement. A negative result means productivity has declined and something needs attention. Solved example 4, change in productivity. Let's return to Flatbush Deli. After reorganizing the kitchen, the same 4 workers now produce 560 sandwiches in the same 6-hour shift. Period 1 productivity was 20 sandwiches per labor hour. Period 2 productivity is 560 divided by 24, which is 23.3 sandwiches per labor hour. The percentage change is 23.3 minus 20 divided by 20 times 100, which equals positive 16.5%. Productivity improved by 16.5%. That is a meaningful operational gain from what might seem like a simple change in kitchen layout and staffing. Additional example, change in multi-factor productivity. Here is an important scenario you will encounter in real business decisions. The Flushing print shop invests in a new digital press. Output rises from 500 to 650 orders per week, but input costs also increase slightly from $4,000 to $4,200 because of the new equipment. Did the investment pay off in productivity terms? Period 1, MFP was 1.50. Period 2 MFP is 7,800 divided by 4,200, which is 1.857. The percentage change is 1.857 minus 1.50 divided by 1.50 times 100, which equals positive 23.8%. Even though inputs went up, output went up proportionally more. The investment improved multi-factor productivity by 23.8%. This is exactly the kind of analysis that justifies capital investment decisions in operations management. Productivity drivers. Now that we know how to measure productivity, the next question is, what actually moves the needle? What can managers do to improve it? 5 productivity drivers. The text identifies 5 primary drivers of productivity: labor, the skills, training, and motivation of the workforce; capital, investment in better equipment and technology; management, the quality of process design, scheduling, and systems thinking; technology, automation, software, and innovation that allow more output per unit of input; and quality, because fewer defects mean less rework, less waste, and more usable output from the same inputs. The most sustainable productivity gains come from improving all 5 simultaneously, not just one. Productivity in services. One important caveat: productivity is harder to measure in service operations than in manufacturing. When a factory produces 500 widgets, output is easy to count. But how do you measure the output of a hospital, a law firm, or a university? The output is often intangible. Quality varies with every customer interaction, and the customer is frequently part of the process. The practical solution is to define clear output proxies, measurable stand-ins for quality output. A hospital might track patients treated per nurse per shift. A call center might track calls resolved per hour. These are imperfect but useful. Practice problem. Before we close, here is a practice problem for you to try on your own. A Midtown Manhattan accounting firm processes 240 tax returns per week, using 6 accountants each working 40 hours. After adopting new tax software, output increases to 300 returns per week with the same staff. Calculate labor productivity before and after, and find the percentage change. Post your work to the discussion board. I will review the answers there. See you in the next lecture. Key takeaways. Let's recap. Productivity is the ratio of outputs to inputs, the most fundamental measure of operational efficiency. Labor productivity measures output per labor hour. Multi-factor productivity combines all inputs for a complete picture. To measure change, use the percentage change formula. 5 key drivers move productivity: labor, capital, management, technology, and quality. And in services, use clear output proxies. In our next lecture, we move into operations strategy, how firms use OM decisions to compete. See you there.